Problem 1, we need to find some areas of some standard quadrilaterals. The area of the trapezoid is base 1 plus base 2 times the height divided by 2. Doesn't matter which one we pick as base 1 or base 2, so 16 plus 29, that is going to be multiplied by 10, which is the height, divided by 2. Handy dandy calculator tells me it's 225 centimeters squared. The area of a parallelogram is the same as the area of a rectangle. It is base times height. The base is 4, the height is 7. And that gives me an area of 28 meters squared. The area is diagonal 1 times diagonal 2 divided by 2. The first diagonal is 16, the second diagonal is 7, so we plug them in. Plug it into our handy dandy calculator and we get 56 inches squared. Problem 2, we're going to be working with this cylinder. The diameter is 18, which means the radius is 9 centimeters. To find the circumference, we know that the circumference is 2 pi r. We know the radius is 9, so we plug that in. And with help from a calculator, we find out that the circumference is 56.55 centimeters. To find the area, it is pi r squared. And for r, we're going to plug in 9. And when we plug that all into the calculator, it tells us that the area is 254.47 centimeters squared. For the lateral area, it is going to be the circumference times the height. But we know the circumference is 56.55 and the height is 2. Plug it into a calculator, we get 113.10 centimeters squared. To find the surface area, we're going to take the lateral area plus 2 bases. The lateral area is 113.10, and the 2 bases are 254.47. Plug that into the calculator, and we get 622.04 centimeters squared. The volume is the area of the base times the height. The area of the base is 254.47, which we found earlier, times 2, which is the height. Plug that into the calculator, and we get 508.94 centimeters cubed. Let's start with a square pyramid. Find the perimeter of the base. We need to know the number of sides and the length of the sides. There are 4 sides and the lengths are 6. 4 times 6 is 24, so we got 24 inches for the perimeter. For the area of base, it is base times height. That'd be 6 times 6, which leaves us with an area of 36 inches squared. To find the lateral area, since it's going to be a stabby thing of the flat type, it is 1/2 p times slant length. We know the perimeter is 36, and we know that the slant height or slant length is 5. Punch those numbers into the calculator, and we get 90 inches squared. To find the surface area, we're going to take the area of the base and add it to the lateral area. But we know the base is 36, and we know the lateral area is 90. 36 plus 90 is 126 inches squared. To find the volume, we have a pyramid, and a pyramid is very stabby, so the fraction is going to be 1/3. 1/3 the area of the base times the height. But we know those numbers. The area of the base is 36, and the height is 4. Plug it into the calculator, and we get 48 inches cubed. Problem number 4, let's do a prism. For the base, the number of sides is 8 because it's an octagonal prism, and the side length is 6. On the perimeter of the base, we're going to take the number of sides and multiply it by the side length. That would be 8 times 6. So the perimeter is 48 feet. Next, we're going to use the area formula for a regular polygon. We're going to use the complicated one because we do not have the apothem, and we do not want to have to take the time to calculate it. We do need to know what theta is, and so we're going to take 360 and divide it by the number of sides, which gives us 45. Plug in the numbers we know, 8 sides, 6 side length, and 45. Plug this in the calculator, and we get 173.82 feet squared. Remember to make sure that your calculator is in degrees, not radians. Next, we're going to look for the lateral area, which is the perimeter times the height. The perimeter is 48, the height is 15. Plug in the calculator and we get 720 feet squared. To find the surface area, we're going to have to add together 2 times the base plus the lateral area. But we already found all those numbers. It'll be 2 times 173.82 plus 720, which the calculator tells us is 1,067.64 feet squared. Now we need to find the volume. The volume is the area of the base times the height. And we know the area of the base, it's 173.82, and we know the height, 15. Plug it into the handy dandy calculator, we get 2,607.3 feet cubed. Problem number 5, there are not a lot of questions. First, we're looking for surface area. The surface area of a sphere is 4 pi r squared. Since we know the radius of 11, we plug it in for r. Plug it into the calculator and we get 1,520.53 inches squared. Next, we need the volume formula for a circle. Volume is equal to 4/3 pi r cubed. Again, we know r is 11, so we plug it in. Punch those numbers into the calculator, we get 5,575.28 inches cubed. Problem 6, we're going to start with a cone, or the stabby round thing. To find the radius, it is clearly marked. To find the circumference, we know the formula is 2 pi r. Since r is 6, we plug that in, multiply it all out, and we get 37.70 millimeters. To find the area, it is pi r squared. Since r is 6, we plug it in, type the numbers in the calculator, and we get 113.10 millimeters squared. We're going to find the lateral area of a cone, and because it's stabby, it has a fraction. This one will be 1/2 because it is the flat fraction. So the lateral height is 1/2 times the circumference times the slant height. To find the slant height, we're going to use the right angle, where the sides are 6 and 13. We need to find the hypotenuse. We'll use a squared plus b squared equals c squared, which is 14.32. Then we plug in the numbers we know. 1/2 times the circumference, which was 37.70, times the slant height, which is 14.32. And we get 269.93 millimeters squared. To find the surface area, we need to find the base and the lateral area, both of which we already figured out. So we're going to take that 113.10 plus the 269.93, leaving us with a surface area of 383.03 millimeters squared. To find the volume, we're doing a 3D stabby thing, so volume is equal to 1/3 base times height. The base is 113.10 and the height is 13. Plug it into a calculator and we get 490.10 millimeters cubed. So what we're going to do is we're going to rotate this circle around the line in a never-ending loop. So let's just imagine that the circle goes all the way around and appears on the other side of the line. Because it's turning around, it's going to give us this nice round shape, which a taco isn't. You also might notice that the two circles aren't touching, which means there's going to be a hole in the center, which a pizza does not have. And neither does a hamburger. So the answer is A, donut. For problem 8, we're going to take this weird shape and we're going to rotate it around the line. Notice when I flip it over the line, the two lines are touching. We'll ignore the handle because, maybe that's just a flavor thing. But there's also the saucer. Also notice that it's short on the bottom and the widest at the top. So it's not A. While there is a dip on the top like the banana, there's also a dip on the bottom, not like the banana. And I hate broccoli, so not D. That leaves us with the apple. If we remove the stem and the leaf, it actually sort of really matches up with that shape. So plane of symmetry is a line that if you cut through the image should cut it into two equal parts. So for A, real quick, I find that flower in the bottom and it doesn't have a match on the other side. So there is no way to cut it that I could have a plane of symmetry. For C, I can cut a line right down the middle of the airplane and it breaks up into two equal halves. So this one does have a plane of symmetry. It only has one. Now B is complicated. I can cut it down that one line and I can cut the basketball into two halves that are identical, mirror images of each other, if I'm including the lines built in on the basketball, which means there's also another one that I could cut a different direction across. And if we're not worried about the lines on the basketball, there's an infinite number of planes of symmetry, which was a long way of saying yes. For D, the whisker curves up, it doesn't match on the other side. The tail is at a weird angle, so it doesn't match up with the head. If you go really close in on the face, maybe. But the easy answer is just no.